Hello everyone. In this video, we're going to take a look at time elasticity and the demand curve. So first up, we have animated figure 4.2 from your book, and we're looking at a regular vertical demand curve. P1 and Q1 show our immediate run, which means that there would be no change in the quantity demanded. QD remains at Q1, and there's no time at all to adjust. Now, even with this vertical demand curve, the second click is showing us the short run. We have a little time for adjustment. QD will fall to Q2, which is just a slight decrease. In the long run, we have a lot more time for adjustment, and that means that demand will become more elastic and our quantity demanded will fall all the way to Q3. Overall, this is just meant to illustrate that in the immediate run, we don't have any time to adjust. The short run, we have a little bit of time. And then in the long run, we're able to adjust demand and quantity supplied accordingly. The next thing I want to talk about is the relationship between slope and elasticity. Elasticity and the slope of the demand curve are related, but they're not the same thing. In fact, when we have linear demand curves, the slope is going to be the same at all points. The elasticity will be different at all points, and elasticity will decrease or become more inelastic as we move down and right along the linear demand curve. Let's look at the difference between slope and elasticity graphically. So this particular line is highly elastic. It has the elasticity of demand is negative 9.1. Relatively elastic would be an elasticity of demand of negative 2.3, and then unitary when elasticity of demand is negative 1. It's inelastic as we have our elasticity of demand being greater than negative 1 at negative 0.4, and highly inelastic as we move even further from that negative 1 at negative 0.1. When we take a look at price elasticity of demand and total revenue is going to be the amount that a firm receives from the sale of goods and services, and it's calculated as the price of the good times the quantity sold. Elasticity does relate to total revenue, so firms want to know how changing their prices is going to affect their total revenue. This is an example that's using that percent change in quantity demanded over the percent change in price formula. And it's showing you what happens as prices go from anywhere from $5 per drink all the way down to giving out free drinks. So you can see here that when we move from $5 to $4, it's a 22% decrease in price. It's a 200% increase in the quantity demanded. It's highly elastic. In this case, from $4 to $3, it's a 29% change in price, a decrease. A 67% increase in demand, it's relatively elastic. As we move from $3 to $2 per drink, it's unitary because our percent change in price is equal to our percent change in demand. And then we become relatively inelastic and eventually highly inelastic as we move from $2 to $1 and $1 to $0. Now, what's important for you as a student here is to be able to calculate and plug into this formula. So I would recommend to kind of pause the video and just make sure that you're able to calculate these same elasticity of demand numbers, and that you're able to interpret that anything that is less than -1 will be more elastic, and anything that's greater than -1 will be relatively inelastic. The next thing that we're going to look at is more on the price elasticity of demand and total revenue. Graphically, we want to look at these trade-offs when a firm changes the price of their goods. So an increase in price, it would be good news if we received a higher price per unit, but the bad news is that we're going to sell fewer units. If we lower our prices, the good news is we'll sell more units, but the bad news is we're going to get a lower price per unit. Now, the big assumption here is that all units are sold at the same price. We're not price discriminating here. That's something we're going to deal with a little bit later. So here's that graph that we were talking about. And you can see that as our price falls from $4 to $3, we're losing $1 in profits, but we're gaining a higher demand. In all of these other areas, you can see that we're gaining a little bit here. So we went down, we're losing $1 in profits, but because that demand is going up, we're earning these $3 right here. So bad news, good news. Per unit, we're losing money, but overall, we're going to gain more and revenue is going to rise. In the elastic region of the demand curve, lowering the price will increase total revenue, and the gains from increased purchases, which is going to be a shaded area that we'll see a little bit later, will make up for those losses. Now, on this graph, we're taking a look at animated figure 4.4b, and you can see that when the price is dropping from 3 to 2, we have unitary demand. We're losing $2 and gaining $2, so we're not really getting anything there. The good news is equal to the bad news, and overall, it's kind of a wash. When we move from 2 to 1, you can see that we're losing $3 and only gaining $1. So this is going to be what our inelastic region looks like. So suppose a firm is selling a product at a price on the inelastic portion of the demand line. The firm could increase revenue by doing what? And the correct answer here is that we would want to go ahead and increase the price, but sell fewer units. So even though we would sell less units, we actually would still be making more money. Keep in mind that changes in income will shift the demand curve, and the question we ask here is how much? Well, that depends on elasticity. So this is measuring how a change in income will affect spending. Price isn't that only variable that determines how much of a good we buy. Other factors like our income will affect this consumption. A different type of elasticity with different variables is going to be income elasticity. And we're asking how sensitive our consumption is with regard to changes in our specific income. So last up, we know that E1 can be positive or negative. Normal good E1, or elasticity of income, I'm sorry, rather than E1, will be greater than 0. For necessities, the elasticity of income will be between 1 and 0. And income elasticity of demand is equal to the percent change in quantity demanded divided by the percent change in income. So the numerator in the formula is the same. The denominator is just the percent change in income rather than the percent change in price. And this is something that you'll calculate just like you would with some of those other slides that we looked at for that percent change in demand based on changes in price. That's going to wrap up this video. If you're feeling good about it, you can go ahead and head over and watch the video on the price elasticity of supply. Otherwise, please don't hesitate to reach out and I'll be happy to answer any questions that you have. Thank you.